Hi, welcome to my channel. Today's final exam exercise is on perforation, asymptotes and vectors. So the level of this exercise is equivalent in your country to this level. Now let's dive in. And here we have today's assignment. Let's start with first carefully reading the description. For each value of a, the function fa is given by fa of x equals 4x squared minus 10x plus 4 divided by 2x minus a. X in this case cannot be 1/2 times a because otherwise we would have 0 in the denominator and that's not allowed. The graph of f5 has a vertical asymptote and an oblique asymptote. The two asymptotes intersect each other at an angle beta, where beta is measured in degrees. In the figure, the graph of f5 with the asymptotes and angle b is depicted. Now let's have a look at this graph. We indeed can see the angle beta depicted there. We see the two asymptotes. But now if we give it a bit of extra thought, we can see that this angle beta appears also on other places, such as here, but also right here, because this is z angles. If we have the beta here, and if we defined an alpha ourselves right there, then we can see that alpha and beta together are 90 degrees, a straight angle. So how to approach this exercise? We must devise a strategy. I would say that we calculate the formula of the oblique asymptote. From that we calculate alpha and then determine beta from it. Let's start off with rewriting the formula for the case where a is 5. Then we get f5 of x equals 4x squared minus 10x plus 4 divided by 2x minus 5. We can solve this by taking a long division. But in our case, we're going to approach it differently. We are going to try to rewrite this term for x squared in the numerator in terms of the denominator. So we would have an equation something like this. This equation, as it is incorrect. So let's try to make it correct. First, we're going to add a 2x here. Then we would get 2x times 2x is 4x squared. But we would be left with the term 2x times minus 5 is minus 10x. In order to negate that, we're just going to put a plus 10x right here. So now the equation is correct. And we're going to substitute it in the formula for f5 of x. Then we would get this, and remember that this is 4x squared. Now we're going to simplify this formula until we come here, and we can see that in the first term 2x minus 5, both in the numerator and the denominator, they cancel out. And therefore the simplest way of writing this equation would be 2x plus 4 divided by 2x minus 5. And now focusing on this second term, 4 divided by 2x minus 5, if the x goes to plus or minus infinity, then this entire term would be 0. And therefore, the equation of the oblique asymptote would be y equals 2x, 2x being the remaining term right here. And now we found the equation for the oblique asymptote. Now alpha is the angle between the oblique asymptote and the x-axis, and there's two ways of calculating this. First, the trigonometry way. The tangent of alpha is equal to the opposite side, which is y, divided by the adjacent side, which is x. So y can be written as 2x, so then we get 2x divided by x x's cancel out, and then we have 2. So tangent alpha is 2. Thereby alpha would be the arctangent or the inverse tangent of 2, which is 63.4 degrees. And thereby beta, being 90 degrees minus alpha, is 26.6 degrees. Another way of solving this is through vectors. First, we have the vertical asymptote. It's vertical, so there is no movement in the x direction. But there is movement in the y direction because it's vertical. And secondly, we have the oblique asymptote, where we can see that for each step of 1 in the x direction, it goes 2 steps in the y direction. Then the cosine of beta is defined as the inproduct of both asymptotes divided by their absolute values, which is 2 over the square root of 5. And then beta would be the arc cosine of 2 over square root of 5, which is 26.6 degrees. And here we have the second part of the assignment. So it starts out the same as the previous assignment. For each value of a, the function fa is given by fa of x equals 4x squared minus 10x plus 4 divided by 2x minus a, with x is not half times a. Now here it comes. There are values of a, such as a is 5, see in the figure, for which the graph of fa has 2 peaks. We refer to the peak with the smallest x coordinate as the left peak. There's a value of a for which the left peak lies on the y-axis. And the exercise here is to calculate exactly for which value of a the left peak lies on the y-axis. Now again, we need to come up with a strategy on how to approach this exercise. I would say that a property of a peak is that the derivative of the function is 0. So our strategy will be to determine the derivative of function fa and make it 0 and solve. So the derivative can be written in different ways. This is one way, and f extent of a of x is the other one, right here. And now we know that the derivative of fa of x is found by taking the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator squared. Working away the brackets leads us to this expression, and further simplifying leads us to this expression. This is the derivative of fa of x. Now we know for a peak this must be 0. That means that the numerator must be 0. And here we have a quadratic expression, which can always be solved with the famous ABC formula, where a is 8, b equals minus 8, and c equals 10a minus 8. Because of the plus minus in the expression for the ABC formula, there are 2 solutions here. The first one is minus 8a plus, and then the square root, divided by 2a is 2 times 8. The second solution is minus 8a minus, and then again the same expression. Now we know that for the left peak, the x must be smaller than the x of the right peak. So we need the smallest of the 2 x's, which would be this one. So this formula now needs to be further simplified. And if the left peak is on the y-axis, if x is 0. That is a property of being on the y-axis. So that means that the numerator here must be 0. And further simplifying this expression, solving for a would be this, and then we get this. And here we have the answer. A equals 4 divided by 5. Here we have the third and final part of the assignment. It starts out the same for each value of a, and so on and so on. We have read that already. So there are two values of a for which the graph of FA forms a line with a perforation. The exercise here is to calculate exactly, for the larger of those two values of a, the coordinates of the perforation. Let's first remember what a perforation actually is. A perforation is a point where the function doesn't exist. Numerator and denominator are both 0. So now we must devise a strategy. How are we going to approach this exercise? I would say that we start by calculating for which x the numerator of fa of x is 0, and secondly use this answer to determine which value of a makes the denominator 0. Okay, so here we have the function again, the numerator being 4x squared minus 10x plus 4, and this should be 0. So that would be a straightforward quadratic formula which can be solved with the ABC formula. This is perfectly fine, this is a good way to proceed, but just to show you that there's also another way, we're going to factorize. Focusing on the numerator, we can see the 4x squared. If we want this to be the result of a multiplication between two bracketed terms, then we should start each of the bracketed terms with 2x. But now the question is, what shall we fill out on the dotted lines so that it would be the same as the numerator in fa of x? Then we can focus on the last term, the 4. We know that the multiplication of the dotted lines should be 4. And now there are 4 ways of getting there. 2 times 2, or minus 2 times minus 2, or 1 times 4, or minus 1 times minus 4. And now we're going to simply try each of these 4 options in the numerator and see what happens. It turns out that if you take the last one, minus 1 times minus 4, that is the correct answer to get the numerator in the original fa of x back. So here we are, fa of x equals 2x minus 1 times 2x minus 4 divided by 2x minus 8. So the numerator is 0 for x is either a half or x is 2. Thereby, substituting this in the denominator, we can see that the denominator of function fa of x is 0 for a is 1 if you used x is half, or a is 2 if you used x is 2. Now, the assignment here says that we need to choose the larger of the two values of a, which is 4. And here you can see the expression if you have filled out a is 4 in the function of fa of x. Now we're going to let the x walk towards 2 in this expression. So then we have limit x goes to 2 of this expression, and you see that in the numerator and the denominator the term 2x minus 4 can be cancelled. So then we're left with the limit x goes to 2 of 2x minus 1 is simply 3. Now the coordinates of this perforation are x is 2 and f4 of x is 3, so 2, 3. That was a lot of fun. Thanks for watching. Hope you liked it. Please leave a like and subscribe, and hope to see you in the next one.